Okay, let's unpack this. Imagine a world where the AI systems we rely on every single day, think self-driving cars,
Hmm.
medical imaging,
Yeah.
could be tricked into seeing something completely different from what's actually there, even when the images look identical to you and me. Today, we're taking a deep dive into a groundbreaking new technique that does exactly that. We're talking about RisingAttacK, a new way of attacking AI vision systems. We've pulled together insights from a research paper, university press releases, and even a public GitHub repository they put out. Our mission today is really to understand what this attack is, why it's a significant vulnerability, and what it means for the future of AI security.
Yeah, it's a really fascinating area, mainly because it exposes these fundamental challenges in how AI actually perceives the world. And by extension, how much we can really trust its decisions,
Mhm.
especially in critical applications.
Right, it makes you question things.
It really forces us to confront how fallible even these advanced systems can be.
And what strikes me here is just how deeply these AI vision systems are integrated now. It's not just like sci-fi concepts anymore, is it?
No, not at all.
They're woven into our daily lives, guiding autonomous vehicles, helping out in healthcare, powering security tech.
Exactly. And that's where it gets critical. Because they're so widely adopted, any vulnerability, well, it can directly affect human health and safety. It's not just theoretical.
Can you give an example, like where's the biggest risk?
Sure. Think about the precision needed for an autonomous vehicle. It has to correctly identify traffic signals, pedestrians, other cars, milliseconds count.
Right.
Or consider an X-ray machine where an AI system helps diagnose conditions. If these systems can be manipulated, even subtly, the consequences could be severe, inaccurate diagnoses or really dangerous situations out on the road.
Yeah, I can see that.
So identifying these vulnerabilities like the researchers are doing here, they stress this. It's an essential first step. It's how we start making these AI systems truly secure.
Okay, so let's nail down the basics. What exactly is an adversarial attack? In simple terms.
Okay, so at its heart, it's when someone intentionally manipulates the data being fed into an AI system
Right.
to control what that system sees, or maybe more importantly, what it doesn't see in an image.
And the kicker is.
The kicker is these manipulations can be incredibly subtle, so subtle that, you or I wouldn't even notice them just by looking.
Like an optical illusion, but specifically for the machine.
That's a great way to put it. Exactly. The core idea is creating what they call a perturbation.
A perturbation.
Yeah, it's just a tiny change. Often it's imperceptible to us. So to a human, two images might look identical, both clearly showing, say, a car or a stop sign.
Okay.
But to the AI, one image shows the object, but the AI completely fails to recognize it. Or maybe it even sees something else entirely. It's not about fooling a human eye. It's about tricking the AI's perception at a really fundamental level.
Which brings us to RisingAttacK. So this isn't just another one of these attacks.
No, it's described as a novel method. It was developed by U.S. engineers over at North Carolina State University. The team was led by Tianfu Wu, Thomas Panyagor, and Chinmay Sivadakar.
And they found a new, you said, highly effective way to manipulate these systems.
That's right. RisingAttacK, essentially, it's designed to be very precise. It uses a series of operations to make the fewest possible changes to an image
Okay, fewest changes.
while still achieving the attacker's goal. So first, it identifies all the visual features in an image. Then it figures out which of those features are most important for the attack.
Like what makes the AI see a car.
Exactly. Which features are key for the AI to identify that car. Then it calculates how sensitive the AI system is to changes in those specific features. This allows for really small, very targeted alterations.
And the end result.
The end result is that a human might clearly see a car in two images. They look the same to us with the AI. It only sees the car in the first one. It completely misses it in the second, thanks to RisingAttacK.
Okay, now here's where it apparently gets even deeper. The paper talks about going beyond just the top prediction. It's called an ordered top K white box targeted attack. That sounds complex. What does that mean for us?
Right, that ordered top K part is really significant. So many previous attacks just focused on changing the AI's single best guess, the top one prediction.
Okay.
But RisingAttacK can do more. This top K idea reveals a much deeper vulnerability.
How so? Why does looking beyond the first guess matter that much?
Well, think about real-world systems. Many safety-critical ones, like face unlock on your phone, or maybe medical triage systems, even content moderation.
Hmm.
They don't just rely on that single highest-ranked prediction.
Oh, okay. They look at more options.
Exactly. They often reason over entire ranked lists of outputs, maybe the top 3 or top 5 possibilities.
I see.
So RisingAttacK can manipulate a trained deep neural network, one of these AIs, to predict any specified K-attack targets, say, 5 specific wrong things in any given order you want, as its top K predictions.
Wait, any order. So the attacker dictates the entire list.
Pretty much. The attacker gets much finer control over what the AI thinks it's seeing. And this makes it easy to evade the simple defense mechanisms that just look for whether the top one prediction changed.
Because the whole list is wrong, but maybe in a specific controlled way.
Precisely. And this kind of comprehensive control, this top K analysis, it's actually being demanded more now. Regulatory bodies like NIST, that's the National Institute of Standards and Technology, they're now recommending evaluations look beyond top one, using K greater than 1 for security testing.
That makes sense. So they tested this.
Oh, yeah. The researchers actually demonstrated manipulating up to 30 targets. K equals 30.
30.
30. Imagine the AI seeing crutch as its top prediction, then wood rabbit, then prison, then jigsaw puzzle, and so on, all in a specific order chosen by the attacker, even if none of those things are actually in the image.
Wow. That's a whole other level of manipulation.
It really is. It's like completely scrambling the AI's interpretation of reality.
So how effective was this in their tests,
Yeah.
in practice?
Well, they put RisingAttacK through its paces. They tested it against 4 of the most commonly used vision AI programs out there right now: ResNet 50, DenseNet 121, ViTB, and DEiT-B.
And the results?
The technique was effective. It worked at manipulating all 4 of those programs.
Okay, that's significant.
Definitely. They ran extensive experiments using the standard ImageNet 1K classification benchmark.
Yeah.
And they tested across 6 different ordered top K levels, starting from K1, just changing the top guess, all the way up to K30, like we just discussed.
And compared to other methods?
Crucially, RisingAttacK consistently outperformed the previous state-of-the-art attack, which was called quad-attack. It showed higher attack success rates across the board. This research, it goes into a lot of detail about how these perturbations are actually formed. They talk about iteratively learning linear combinations of singular vectors of the Jacobian.
Yeah.
It gets technical.
Right.
But the key takeaway is its effectiveness. And this work, it's actually set to be presented very soon at the International Conference on Machine Learning, ICML, on July 15th.
Okay, so looking ahead, what's the bigger picture here?
Well, connecting this back, they've shown how powerful it is on vision models, right? Images. But the researchers are already thinking about how effective it might be against other types of AI.
Like language models?
Yeah.
ChatGPT and things like that?
Exactly, like large language models. That's an area they're looking into. But the overarching goal here, it isn't just about finding ways to break things.
It's about defense.
It's about defense. The goal is to use this knowledge, these powerful attack methods, to develop really robust techniques that can successfully defend against these sophisticated attacks. Offense informs defense, essentially. And to help with that, they've actually made RisingAttacK publicly available on GitHub.
Oh, interesting. So other researchers can use it.
Yep. The whole research community can use it to stress test their own neural networks, push the boundaries, and ultimately build stronger, more resilient AI systems.
That's good. So this deep dive into RisingAttacK, it really underscores how intricate AI security has become and how vital. It's not just about what the AI thinks it sees.
No. It's about what an attacker can potentially force it to see.
Yeah.
And, just consider how much we're already trusting AI vision right now in our daily lives. Unlocking phones, medical diagnoses, security cameras.
It's everywhere.
It is. So as these systems get even more sophisticated, the big question is, how do we ensure their eyes are truly seeing what we intend them to see and not what some hidden attacker wants them to see? What steps, maybe what fundamental breakthroughs in AI defense do you think are most critical for society to take to really build trust in AI's perception capabilities long term?
That's the crucial question, isn't it? Something definitely to think about. Thank you for joining us on this deep dive.